what's up everybody? Welcome back to another 3D Hangout. I'm Noe, designer here at Adafruit. Joining me every week is Mr. Pedro.
What's going on, everybody? I'm Pedro Ruiz, creative tech here at Adafruit, and every week we come to share 3D printed projects featuring electronics from Adafruit.
That's right, this is still the same show. We combine 3D printing and DIY electronics to make inspirational projects. See, we said that at the same time.
Welcome to 2018. Hope you all had an awesome holiday off and an awesome new year. We're back.
We're fully rested.
Yes.
Yeah, this is episode 167. Thank you so much for joining us today. We are live streaming on YouTube, Facebook, Twitch, Periscope, and I think that's all of them. Let's start off the show by paying some bills with the coupon code.
This week's coupon code is Timelapse because of our project finally this year.
Finally.
Yes. It takes quite a while to make some projects. Use
Yeah.
coupon code Timelapse to get 10% off your order on anything that's still available. Looks like everything is out of stock, at least for this project.
We're sorry about that, but we're also thankful that you guys did that for us. Thank you so much.
Yeah, thank you. It's a good problem to have. We still have freebies. If you check out adafruit.com/free and check out different tiers of different goodies you'll get at different price ranges. So check that out. We also got same-day delivery for the fine folks in New York.
What else do we have?
We got daily news, all of your categorized newsletters.
You gotta go to adafruitdaily.com to subscribe to that one. It's not tied to your account. We also have another one that's product specific. This one's called the new letters.
One of our most popular newsletters.
Yeah, it is.
Just
Thank you for
subscribe to that.
That's right. You also have to subscribe to that one. Saying a good, warm welcome to everybody in the Discord chat room. Thank you so much for joining us in the Discord chat room. We'll take a look at the Show and Tell channel and take a look at what folks in the community are working on. But now we're going to take a look at this week's Noe Pedro project. I have a learning guide this week, guys. Last week we wore out. This week we're back. This is the learning guide. It is fresh, published. I published this last night, 12 a.m. along with the video. Yeah, this is one of those projects where you're working on it till an hour before you publish it. That was a lot of fun. So hopefully you checked out the video. If you haven't already, please give it a watch. It is a 5-minute video of kind of showing the workflow of using the camera slider as opposed to building the camera slider. You want to learn how to build it? I got the learning guide for you. So we're going to walk through the learning guide, and it's my pleasure to show you guys the assembly and all that stuff. So the parts list is basically the same part lists for the original camera slider. There's an original camera slider? Yeah, there's an original camera slider. We worked on this about 3 or 4 years ago, and this uses it used an Arduino Uno and a motor shield with the Bluefruit module, and it was pretty simple. You couldn't mount it to a tripod, and that was really the main thing I wanted to improve on it. There's also a lot of CAD work done to it, but it now uses 2 aluminum extrusion rods to make it just better supported, so there's less kind of grinding on the timing belts. So it's a much more smoother and it's just less shakiness. There's some extra hardware pieces. Everything is listed out here, including the T-nuts and all the little things that make it kind of work. It's still very modular, so it's free to kind of add on to it. Let's talk about the software. The software is the exact same from the previous project. It is using the Arduino IDE. It's using a couple of libraries like the Motor Shield library and the Bluefruit SPI library to communicate over the Adafruit Bluefruit app, which is an app available for your mobile devices, whether it's Android or iOS. We got both of them flavors. And the only things I did was kind of change up the speed here. So if you look at this array, you can change the speed, which is really the total length of the slider. How long will the slider take to move? And depending on that, you can set your intervals for taking pictures to generate your time lapse. Or you could also just use it as a regular video slider and make it slide at full speed. At full speed, it takes about 1 minute and 20 seconds to go through the whole slider, which is 500 millimeters long. Circuit diagram hasn't changed. It's still using a Motor Shield V2 for the Adafruit Arduino, the Adafruit Metro. The stepper motor is a NEMA 17 stepper motor. So your kind of standard stepper motor, 4-wire connection that goes into the screw block terminal. You do need to solder the Bluefruit SPI friend on top of the prototyping area of the motor shield, but it fits perfectly on there, and there's plenty of room to connect wires. Let's talk about the 3D printing. There is definitely a lot more 3D printed mounting pieces to some of this project, as there's just more pieces to it. So everything is broken out here, and I've printed it in PLA in different colors to kind of showcase the different segments of the assembly. Of course, the Fusion file is available to download. Let me click on that link and make sure it's actually working. I think it is. Yeah, it is. I think it is. It's a fairly large assembly, so if you would like to download this, it is free. You can use the download link at the top here to download in Fusion 360, or if you're like a SolidWorks person or Tinkercad, you could download it in any of these formats like STEP, or OBJ, or SketchUp, whatever works for y'all's. So all the parts and components are modeled, including some of the boards, battery pack, and that sort of thing. I would like to do a layer by layer on kind of taking a deep dive into the CAD, as it was a pretty neat undertaking to make this assembly. So it's very, I don't know how to say it. There's a lot of parts to it, so it's fun. You can download the STLs, however, if you just want to get down to making it. I talk about a little bit of things like the tolerances. There's always a problem with tolerances. Oh, my screw didn't fit, and that's because the extrusion layer line is different, all that sort of stuff. So just to kind of be aware of that. If the screw holes aren't the exact same size, it's just kind of the nature of using different materials, different temperatures, and that sort of thing. Let's go on to the assembly. So I broke this up into sub-assemblies, so you can basically make little sub-assembly pieces and then bring them all together near the end of the build. I start off with the stepper motor assembly. It's mounted to 3 separate pieces. There's like a main bracket and then these 2 kind of legs that kind of slot into the aluminum extrusion. And same thing with the bearing mount. It's 3 pieces that kind of get fastened together with hex nuts and machine screws. The tripod mount assembly uses T-nuts that are specifically sized to fit and slot into the aluminum extrusions. I ended up making 2 of these because I ended up using 2 tripods, one on either side of the slider, to just make it very, very stable. Because if you just have one in the center and then you have a 5-pound camera, it tends to do this. It tends to shake because it's 5 pounds and your tripod can only do so much. Onto the extrusion assembly. This is where the 2 sub-assemblies come together. So the motor mount assembly and the bearing idler come together on the ends. They just slide into the grooves here, the T-slotted areas of the aluminum extrusion, and they're held and secured with these T-nuts and M4 screws. Onto the case assembly. This one's a much better design, in my opinion, than the first one that I made, mainly because it is attached to the actual end cap of the bearing mount with machine screws and hex nuts, so it's not going anywhere. My other one kind of slid in, and it didn't really work so well. I had to use hot glue. This time, screws for everything. You do have to do a little bit of threading. So the wires from the motor get threaded through these 2 pieces here, and they go into the Adafruit, not the Adafruit Metro, but on top of the Adafruit Metro, which is the motor shield. I really like the screw block terminals. I wish everything was like this, but this makes it easy to install. Just kind of plug in the pre-tinned wires and fastening up those little screw block terminals. Everything kind of snap fits together inside of the case. There are some hardware screws required for mounting the Adafruit Metro board to the case, but other than that, you have access to the micro USB and the 12-volt barrel jack, the 2.1mm barrel jack. Let's move on to the camera mount assembly. You are going to need some tripod screws. The standard tripod screw threading is a 1/4 20. It's an imperial thing. I'm sorry about that, but I didn't make the rules. To install the camera mount, you need some M5 screws. It's not a typo, it's M5. I actually researched the manufacturer of this pillow block, and they have a technical drawing in their website. So maybe we can bring that into our product page. I'll work on that one. That's a little side note there. But yeah, M5 screws for the threading on the pillow block. That's the thing that slides onto the actual linear railing. Speaking of linear railing, to install it, it slots into those pink legs and is secured with a single machine screw and hex nut on either end total. And these are pretty nice. What I like about this assembly is that the aluminum extrusion really allows you to adjust things and tighten things, because the T-nuts allow you to kind of move things, set it in place, lock it in place, which is really nice because I have to push the two sub-assemblies away so that I can insert the linear rail at an angle, and that slides and slots into the grooves on that pink mount. So everything kind of slides into place and gets locked and secured with nuts and screws. But after we have the rail assembled, then we have to get the belt onto the thing. I start off by installing a radial ball bearing over the bearing mount that just sits in there as an idler. We go ahead and get the belt and fit the teeth over the timing pulley that is secured to the shaft of the stepper motor. And then we work on press fitting the belt into the little groove on the camera plate. That little groove is what will hold on to the, kind of bite into the teeth of the timing belt, so that when the motor turns, it pulls and pushes on that camera slider and just slides. The second slit on the bottom of that groove allows the timing belt to freely slip through there and stay in place so that the linear motion stays nice and sturdy. Let's see, the next thing is to fit that belt over the radial ball bearing. You just kind of fit that in. If it's loose, you can tighten it later. This is one of those assemblies where you want to have everything a little bit loose and then tighten everything at the end of the assembly. To prevent that belt from popping off from the top of the bearing, I made a little bearing cover which cleverly slots in and locks into the base feature of where the bearing sits and rests, so it doesn't go anywhere. It's pretty nice. And then at the end, you can add a belt tensioner if you need. You don't need to, because you can just push the two sub-assemblies away and make the belt really taut. On to the final assembly. This is where we're going to tighten everything up. So just make sure that the belt is nice and tight, and then fasten all the screws and tighten everything up. You might want to adjust where your tripod mount is. I ended up making two, like I said previously, but I tend to switch back to one tripod when I need to do like a slide in as opposed to going left and right. The last part of the guide talks about power. I need to put some photos in here, but you have options. We have 12 volts power adapters for the wall, or you can use a 12 volts power thingy. We have an 8X AA battery pack that works really well. And one of the things I did was actually update this sort of as a last minute. So we'll take a look at that. I added a really nice mounting bracket for this 8X AAA battery pack, so that I can have this portable that plugs into here. This gives you 12 volts. This slides out and reveals the two brackets. These are 4 machine screws, so it's definitely there. I'd like to make them a little thicker, but they're pretty good. The way the cover is set is with our very highly used nubs. So I have nubs, 4 nubs on the sides here, so it clamps on really well. It's still open, so you can kind of change things out if you need to, but for the most part, I think it's modular, and having snap fit covers is always a good thing, even in this case. So that's the latest update I've made to it. that's pretty much it. If there's any questions or anything like that, please drop them in the comments so we can get them in.
First comment was,
put it away.
Sai wanted to know what the cost of the bomb is. So all I did was click on the Add All button on the learning guide, and depending on what products you may or may not already have, it looks like it's about $199.
$200?
Yeah.
Wow, that's cheaper than the panty. That's actually a pretty good price. Now, a lot of camera equipment is very, very pricey because it's kind of machined. And this is sort of the prices that you expect. The additional panning motion controller that I use, you can pick one up, but it's a little pricey. It's $250. And that's because everything is contained. This isn't like a DIY thing. This is something that video professionals use. And boy, does it add dimension to the slider. Because if you're just sliding left and right, yeah, it's cool. But once I added this Syrup Genie Mini, it really added that extra dimension. And it's a little pricey, so maybe we will try to DIY this one. But you're looking at around the same price. So
yeah, if you search online, it looks like they're about $2,000 for a motorized
I thought
slider.
they'd be somewhere around like 500, 600. Ours is fairly short in terms of the length, but that's actually pretty good. It's not limiting for me. It hasn't been a part like, oh man, I wish the slider was longer. That actually hasn't happened yet. Excuse me. And another thing I'd like to do is kind of improve on the software so that we can have like a screen, like a TFT display or something. So maybe that's something later down the line.
Yeah, it's actually another
time to do it. That'd be really cool.
Yeah, so Kirby was asking if you could add a status light to see the speed setting.
So it already does that by default, but I'd have to break out that LED and put it somewhere noticeable. But that is something that's actually in the code that Phil B wrote in there. He wrote it as saying, like, because we don't have a screen, the LED will blink at a certain rate. So you just have to read it. I don't really use it because it's enclosed. I just kind of know in my head. That's probably one of the limiting things about it is the software. But you kind of grow to intuitively understand what mode it's in. I know that's a little bit hard to use, but it's what I have, and it works pretty well for our cases.
Kirby says he broke his out, used a clear cover, so you could visualize that. Yeah,
that's a good idea too. Just print the cover in transparent or white, something see-through.
Yeah, so it's... Yeah, so it's saying that maybe you could integrate the design with the belt so it could turn a gear as it's moved, sort of simulating the syrup.
Oh, wow.
That'd be pretty cool.
That would be cool. Yeah, I really like the Tyler's from Make magazine. He added a TFT OLED, or not a TFT OLED, an OLED display, Featherwing, to his, and that shows what mode you're on, and that is something definitely I would like to do. And it's great that this thing's modular, so we can pop out the case and fit a feather in there, so it's a little bit more smaller maybe. That'd be cool. Stuff for the future. So this won't be the last version. We're just going to keep on improving on it as we do with some of the projects that we just keep using.
Actually show a B-roll of what it actually captures, because the most exciting thing about this project was actually using it.
Yeah.
So much so that we didn't even film any of the build for the video. It was all just pictures for the guide.
That's right.
Because we had so much fun just actually using it. And we noticed that quite a bit of people did build the last iteration of this slider, but they only post like, 1 or 2 videos, and then it looks like they stopped using it, which is what we did as well. We built it, only shot a couple of things with it,
and then didn't use it after that.
Yeah,
mainly because it was limiting, because it was not designed for a tripod. You can't, if you fit it on the desk, you only have so much space to work on the desk, and getting the angle of the camera to see everything on the desk is a little bit tough, because you want to see it down like this. You don't want to see it just on the side.
Yeah, and then because of the relatively small size of it, it gets pretty boring panning left and right for all the shots. So as soon as you added the second little action to it with the Syrup Genie,
So we did a lot of, these are one of the first test shots. I took it outside and filmed one of our planters that we made. And this is just 1 minute and 20 seconds. And this is just using an iPhone. One of the cool things about the iPhone is you don't set any intervals. That's also a bad thing because you can't
control it.
You can't control it. You just end up taking, let's say your time lapse takes an hour of record time and you want to play it back for 10 seconds. Well, you can't really do that with an iPhone because you don't set the second intervals. Anyway, we did a lot of different things, just printing. So a lot of these, I did this experiment where I wanted the ice to melt, but it was a little cold out, so it didn't melt that much. But this just kind of showcases that it is sliding over a period of time. So you can, I don't know, see a flower petal opening. In this case, the ice is melting. It's
or most important for us, some Lego builds. It is the most cool way to make a little time-lapse video of a build for Lego, because you can actually see it being built up. And one of the other cool things, show the acrylic. I
like the Christmas train. We can't show this together.
Any type of builds look really cool on it because you're able to see all of the motion around your area.
Yeah, and this is shot in 4K with the GoPro, so you can zoom in and post and give it even another dimension of movement, which is pretty neat. Yeah, so that's our Christmas tree in our living room. Pretty neat. Yeah, that's about all I have.
GoPro painting.
I don't know which one. Those are like regular shots. They're kind of scattered everywhere, so it's going to be a little bit hard. Pedro's latest project is the LED sand thingy, which I guess we can segue into. What are you prototyping, Pedro? This is what you're prototyping.
Yeah, here's just cool? The test of me building out the circuit, because it takes, 1 or 3 tries to find the optimal way of
your wire lengths, for example. Or
more than that, just the order in which you're building everything for the camera.
Are you threading wires, or the wire lengths change? Yeah, it's fairly, packaged really tightly, so you have to really focus on it.
I tried to make it as small as I could. Yeah. So yeah, that definitely segues into this week's prototyping. As you can see here, the slider will be used in everything that we build, or
cramming this in here as much as I can. You had to actually redo it. I see you fitted it in the box in your enclosure, and then you took it out and like reworked it again.
Yeah.
It's just what happens,
In terms of optimized designs for mounting things. So let's go ahead and just jump into the overhead so we can take a look at.
Let's do it.
I think last year, or 2 weeks ago, we showed some of the circuitry that goes into building this super awesome code from our very own Phil B, Paint Your Dragon, on Twitter. Posted really cool prototype of this, and everybody just went nuts over it. Looks so cool. It is a very cool little simulation of LED sand that is being controlled by the LIS 3DH sensor inside here, so it can detect which way the position of it is in space. And we're using the Chartoplex matrix on here to display the LED sand.
Did you give quotes?
Yes.
Yeah, this is
this
fun.
thing looks so
fun
cool.
Physics toy.
Super cool.
Very awesome work, Phil B.
Yeah, so the original idea was having some sort of like gyro or something like that on it, so you could, sort of visualize what that'll look like. So here's what that is like, and it's fortunately too bright if you want to lower down the
I can do
exposure on that. You can like almost see it, not really, because it tends to
it's pretty cool.
Rotate away from you.
But still, it's a print-in-place gyro, which is always a cool thing to do. And it's, I haven't really done this yet, so it's pretty fun to play with an add-on to an enclosure that was otherwise kind of boxy and flat and didn't move.
Yeah, so took a look at some of the gyros that are, or the gimbals that are out there, and Josh from Design Make Teach made a really simple design. I copied that and redrew it inside of Fusion 360, and it printed out excellent as a print-in-place object. And the cool thing about this is you don't have to print it in place. You can actually just assemble this together, so you can print these out in different colors and then just reattach them with the nice little cone nubs that hold everything together. So the second iteration of this, which is the one that I was showing, was having it be a wearable. So we have a nice little pin on the back here, so you can add this to your attire, and it works pretty good. I think the last design for this is going to be one of the original ideas that Phil had was having like a dome on the bottom, so it can like sort of teeter. It'd be a nice little desk toy. And then you have a different version as well, one that's completely exposed using the feather, what is the parametric
yeah, the original
design.
feather box actually won't fit it, so I did have to tweak it a little bit to allow for the LIS 3DH to fit underneath the board. But if you have your Charlie Plex wing and you have one and it already has headers soldered to it, you might want to go with the feather box just because it's designed for a headers.
Yeah.
Headers. Yours is more of like
completely enclosed.
Freehand wiring, I would call it.
Yeah, there's no headers in this. We'll take a look at the way that it's designed next week.
Yeah,
can
so
take
it's a much
quick little peek inside there.
Smaller.
Yeah,
it's a little bit chunkier, but it's still smaller. Very, very packed, as you can see, everything's stacked.
Yeah, I'm pretty proud of the way that it's all mounted in there. Nice, tasty circuit sandwich, and the way that the battery is sandwiched in between the Charlie Plex, the M0.
All sorts of colors from Charlie Plex wings. These are great. There's a lot of cool projects you can do with these things. All, you know, very, very nice use of animations and stuff. Check out the learning guide. We have tons of guides using this, like a flame one, I think was a really good one. So
this will be out next week. And I believe you can get to all of the libraries you need to build this together if you want to start on it now. Yeah, you could upload the code right now. It is on the learning system. We shared it last week, 2 weeks ago, but I'll share it again. Was the unified library, was that a tricky link to get to get all this work? It wasn't private, no. You just have to search for it. Right. Now we'll show it all off next week. Really handy way, and the way it's all mounted. We'll talk about all the design on that, blah, 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 next week. Super cool. Really love this project. Wow, super cool. Like it. I'm looking for Raspberry Pi shields. So under the shop, I'm answering Ian's question here about Raspberry Pi. We have a category on the shop for Raspberry Pi stuff, so I would probably click on Raspberry Pi. Yes, we have a whole section on it. Am I blind? Right there. It's like one of the first things. Yeah, there's a shield thing here. Accessories, maybe it's that one. Pi hats and bonnets. That's another way of seeing it. So we have the motor shield. So if you want to do this on a Raspberry Pi, you can use this. Write it in Python maybe. We also have a 16-channel PWM servo hat. We got a lot of different add-ons for your Raspberry Pi. So check them out. You probably have more than, if not the same as the Arduino shields. So yeah, we got a lot of Raspberry Pi specific shields. Yeah. Check that out. And also some great ones from Pyromoni. Okay. That was, what are you prototyping? We're going to jump into Shop Talk. Shop Talk is where we talk about some tools or some products in the shop that we're taking a look at. Not necessarily a project, but just looking at the components themselves. So this week, we got these. These are LED NeoPixel dots. So these were requested by Aaron St. Blaine. Does a lot of cosplay and was frustrated by the lack of really good NeoPixel dot form factors. The ones we had were kind of the older style. I don't even think they're NeoPixels. Can we turn these on? Oh yeah. So to turn these on, they're soldered into. They come with these connector things, right? So I kind of soldered these to just some other pins except for the data, and then I soldered a JST female connector on the bottom of the Trinket M0, and it's running Circuit Python. So I'm going to plug in this little baby battery. It's like a 105 milliamp battery. Plug it in here. I know it's 3.7 volts, but it's okay. NeoPixels can run it. And I think I hit the reset button on accident. Yeah, it's like, I can't go. This is not working. Demo battery dead? Upset. No, the batteries are not dead. It's just the Circuit Python's like, hey,
What's going on? There you go. Instant reset. There you go. Yeah, I hit the reset button on accident, and CircuitPython was like trying to load something else. So what we're going to do with this, I don't know yet. We have one project on the learning guide, and it's like kind of like you wrap it around the tree, but they're pretty neat because they're encased in these little kind of waterproof things, and they have like these little clips on the edges where you can kind of you can sew them to fabric or something.
I think the good angle is right where you can see.
Yeah, I showed it.
There you go.
Yeah, they're pretty nice, and they're supposed to be waterproof, but we don't recommend you dunk it in water. They're probably okay in the rain. Oopsies. And I don't know, maybe what we'll do is kind of...
So the first idea that we
String
had
around.
is those festive necklaces that you see at theme parks.
Yeah.
They're always like themed to whatever season is going on, so we thought it'd be cool to have a modular shape that you could sort of just screw on to each dot and be able to change it out with the season.
That'd be really cool. So maybe some Christmas trees or whatever, Mickey ears or something. That'd be really cool.
Valentine's, I think, is the next holiday up.
They're just nice because to fabricate your own would be a nightmare. You can do it, but it's going to take a lot of time, which is what you were going to do. Like, I'll wire that, it's no problem. 3 days later. So these are really nice. The pitch is, I believe, 2 millimeters apart, but we have different pitches here, as you can see in the learning guide, or not learning guide, but the product page. The different pitches. I like this one.
Yeah,
there's only 20 of them.
2 and a 4.
2 and a 4 scale. There's the Christmas tree. And I think there's other ones. Yeah, this one here, 4-inch. So this is like, they're more further apart, as you can see here. They're further apart.
And I really like that you are able to have such a tiny little assembly for that. Just a trinket and a battery.
So this is how long it is, and you know, you could kind of
definitely cut that down.
Cut it down if you want. Yeah, I would definitely recommend using a trinket for something really small. There's no USB charging in it, but you know.
Battery's small
Works
enough so
pretty
you
well.
can replace it.
Yeah, I don't know how long this will last. Probably 30 minutes. I don't know.
You can turn down the brightness on it as well.
Yeah. Just wear it like that. So that's our Shop Talk product highlight. Is these little NeoPixels. Pretty neat. We've been looking for some of them, and I'm glad we got them in the stores.
Next up,
bling, no.
I like the way that the.
I feel very blingy.
So jumping into this week's Timelapse Tuesday, there's a really cool cat in a box by Louise Dreggers. She has some fantastic designs like Aria the Dragon, and now she's come out with a cat in the box. Yeah, so instead of trying out the palette, since everybody is always upset about... No, I mean, everybody's always upset about the Purge Tower. Yes. I mean, it's a valid argument. Yes. As I say every week, they are working on optimizations for that. So we just wanted to try out a no-waste print. It's only dual color. All we can do with a dual extrusion on the Ultimaker 3, but it came out relatively well. I used standard settings to print out wood fill, which is the ColorFab wood composite filament, and then just a regular run-of-the-mill black PLA. It did fail on the eyes, but I like how it kind of looks like he's a little smug. Maybe looks like the Garfield tired eye look. Yeah. Like he's so proud that he was able to fit in the box. As some commenters did point out that it does look like there's some blobs and a bit of stridation on the wood fill part. I guess I didn't have it tuned as well as the Ultimaker 2 Pluses did, because they were able to print out the last project that we used wood fill on.
The Adabot voice kit?
Yeah, the Google AI voice kit. Those came out so fantastic.
They really did. Almost too good to where we couldn't,
Yeah, I couldn't actually use the staining on it because it works the best with stridations like this.
It's so small like wood grain. So anyway, it kind of worked here. I mean, it looks like cardboard. It's a cardboard box. However, we would probably benefit if we were to print it at a lower layer height, so 0.1 as opposed to 0.2. Probably clean up some of those edges here. And then the speed too for the outer walls might be a little bit too fast as well, which is probably what was leading to the weird stridation. And
if you can see in the time lapse as well, as the colors are changing between the extruders, it goes over to the side and actually cools the opposite extruder down a bit. So that's probably what's contributing to some of the under extrusion from it trying to heat back up as fast as it can. But definitely
it's not purging at all, so
yeah,
it could benefit from a purge. But they were, you know, attempting to zero waste dual extrusion. This is one of the things. There weren't really any bleeding issues, which is pretty awesome.
Yeah.
But yeah, just the eyes just kind of under extruded a little bit.
And we still want to check out the 0.25 nozzle print cores for the Ultimaker 3. So we'll be checking those out, see if there's any improvement in terms of smaller details for that.
Eye crust, crusty eyed cat.
Looks like he's crying at certain angles.
Aww. So cute though.
But turned out pretty good.
Yeah, so huge shout out to Luis Dreggers, Luby, on the social channels. Looks like a couple people have already made some. So if you'd like to test out your dual extruder printer or multi-material printer, try out the cat in the box.
Yeah, I think the only other thing that I would change to in terms of the setting is I think I had the infill a little bit too high on this, mainly because we thought the eyes would drop down in there as it's printing it up this way, but I don't think that would be a problem. So cool, little cat in box, makes a great paperweight.
All right, that's a part of the community make.
Next up on Discord, if you want to join 24-hour chat.
What are you doing with the cat? Put the cat down.
Check out Discord.
Yeah, let's take a look at Discord. We got some great projects from the community, starting off with sorry. This person here has a really cool Photon smartwatch. That is so dope, man. That is so cool.
Wow.
Look at this thing.
Oh, cool. And it's using
it tells the time. It can do all sorts of things.
Wow.
It has lights. Super cyberpunk. And super dope. Hey, look, they get text messages. It tags you on Facebook.
Oh, wow.
That's pretty cool, man.
Get notifications.
We are Cyborg. We're living in the future, guys. This is really cool. So check out, oh boy, I wish I could say your name correctly. Miming. Maybe it's Miming. Yeah. Very cool. Archie. I can't read these names. It's so terrible. Archie. Let's just call him Archie. Has shared his felt NeoPixel rainbow crown.
That's cool.
I think we shared this on the blog. If not, it is here and is an instructable. So check that out if you're interested in making some cool light up felt projects. That's unique. Rebecca 1313 is sharing her progress on her weather display, which will display the weather using some NeoPixels and what looks like an alphanumeric display. Very cool. Well, we got a make from SDWNJ.
Oh,
made
nice.
One of the tiny TARDIS wearables. That's really cool. You put a coin cell battery and some sequin LEDs to make it light up. It's pretty cool. Mim Ing also is working on the AIY Google project for the Raspberry Pi. Very nice. Cascade whipped up a Boomy avatar Photoshop file if anyone wants to make their own Boomy, like a, you know, change up the thing. We're actually going to print Boomy again on the palette when the palette parts come. Also sharing some new stuff from SparkFun. I believe it's new or not, maybe, for a power supply of sorts. And Boomy is now an avatar, or an emoji. Yeah, I like that. Looks good. Thank you, Danute. Brian published a video on his YouTube channel on how to program an AT Tiny 85 with a DIY shield. So check that out if you're interested. Scoops, Scoops is sharing progress of his RetroPie arcade build. Those are always fun. Ezra Skies is sharing his love for undies. Andes mints. That's really fun. Anna is sharing her EL Christmas stocking on Twitter. It's really cool. It's good shape. Pixelion This is a cool graphic. I just love me some icons and clean graphics. This is the Node MCU on board. Looks really great.
Yeah, I like the yellow.
Yeah, isn't it really cool?
Mm-hmm.
Very clean. Miming is sharing some more progress. The Raspberry Pi project, it looks like. And Miming sharing a bit of a RetroPie project. This is really cool. It sits on top of this probably USB or Bluetooth joystick. Cool. Yeah, I love those formats there. And Deshupu is back with an even better update to his game console. He made it even smaller.
How small?
Look at the Atmel, chip here.
Banana for scale. How about a coin cell?
This is the back scale of it. The coin cell is as big as the whole thing. It's amazing. Wow, how small it is. It really makes Phil B's world's smallest. Maybe not so much the world's smallest. They're in competition now. Who can make the smallest? Yeah, but that's a Pi. This one is a SAMD21, I believe.
Another Galatis
Katika
update.
Has a Galatis update. I don't want to get content ID thefts, but there is some voices going on here that may or may not be copywritten by
maybe
a company. I'm not sure. But yeah, this is really cool. It's more kind of like showcasing it in action here. It's really cool. Wearable Galatis. That's amazing. Nobody must have you. Yeah. Cool. Cascade sharing some Pi tips. That's always nice. A bit of a project help there. Code Reactor is sharing his web interface for the his RGB LED desk lamp. Looks great. This is really cool. Cascade working on a custom build. Oh, using those buttons. I love these buttons. The squishy buttons. They're really nice. And we have Charles Crawford III sharing some CAD progress for Engineering Week 2018 on his Christmas break. This looks really cool. Printing the treads in NinjaFlex. So these will all, I think, connect together. And then Brian is working on KiCad, making his tiny AT-Tiny programming board. That's pretty cool. Great way to start learning PCB design. And then Snag for Life sharing a video here. Early prototype POC. And some more kind of sharing stuff. So if you'd like to share your projects, please share them on the show and tell. Very inspirational stuff out there. Keeps us going. And later tonight we have a show and tell as well. Pedro, tell us about the show and tell.
Every week, 7:30 p.m. Eastern Standard Time. You can join us on the Adafruit Show and Tell. Just go to the Google Plus page. You see all the instructions on there. We'll also post the links to it on the chat on YouTube, and as well as Discord and everywhere else. You can join in, show off your awesome projects to Lamar and Phil in the world. Be there every week for a half hour. And then right after that, we'll have Ask an Engineer, a full hour of Track Talks, news, 3D printing, all of the
Arduino, and more.
All of the awesome behind the scenes and in-work projects that are coming up.
Yeah. Don't forget, folks, if you want to pick up anything in the shop, please use the coupon code Timelapse and you support all the lovely people at Adafruit. Here's a lovely picture in the summertime, reminiscent of when there used to be a sun. It's cold.
Thank you all for joining us. Beginning of this year, we had an awesome one.
Tomorrow, Jump Park Workshop. Keep your eyes peeled for Jump Park. Right? I think
yes.
We're sure. We're not sure. Hey, John. What else, Pedro?
I think that's
the rest of the show. Thank you guys so much for joining us as we get into the new year. And we hope everybody had a safe and warm new year. Good luck with everybody's maker projects, and we'll see you later tonight, hopefully. Until then,
I'll be there.
Keep on blinging.
See you guys.
Bye, everybody.